And I'm so happy to be hosting our second lecture. And this is through the MIT Media Lab. And you're just going to get a notification that we're going to be recording this talk. The transcription will be made, the recording will be made available as soon as we get transcriptions ready. This talk series is being hosted by Future Sketches, which is the group that works at the intersection of technology, art, and design, led by Zach Lieberman. And if you're interested in learning more about the program or applying, we are accepting applicants until December 15th. So with that, I am so happy to introduce Linus Lee. I've been a personal fan of Linus, as I think a lot of programmers are, because Linus kind of takes ownership of the digital tools that he uses in a way that I think all programmers strive to. And I'm going to read the Linus's description. So Linus is an independent researcher investigating AI and its impact on knowledge representation and information tools. Linus currently advises as an EIR at Thrive Capital, bringing experience bridging research and product from Notion, where he was a part of the early AI team. Prior to Notion, Linus spent time writing and building community around AI in HCI, serving as a researcher in residence at BetaWorks. Linus studied computer science at UC Berkeley before taking a leave to join early stage software companies. So with that, let's give it up for Linus.
Hello, everyone. Am I coming through? Can you all hear me?
Yeah, but you're showing the maybe like the presenter view.
No. Okay. Let's try that again. Okay. And where's the keynote? There we go. How's that?
Perfect.
Better. All right. Thank you for having me here. I'm excited to talk about some of the things that's been on my mind. Perhaps some of the more abstract things that's been on my mind. I wanted to take the kind of next 45 minutes or so that we have and spend it sharing some loosely structured thoughts that I had about what exactly are we doing when we are trying to represent information in tools, in particular in kind of software information tools. And so this is just loosely thinking about representations and the implications of working on representations. I'm Linus. I've, for the last few years, been thinking a lot about how to improve the way that humans interact with information. In particular, I spent some time kind of independently tinkering and exploring how we could improve text and humans' relationship to text. Not just the tools that we have to work with text, but text as a medium itself, I thought was interesting. And that led me to join Notion and work there for some time as a part of their AI team, who are still obviously shipping lots of really interesting and high impact features, trying to bring AI into everyone's kind of day-to-day workflows. More recently, I joined Thrive Capital, which is a venture capital firm. They invest in all kinds of companies and people and ecosystems. And a lot of that work is also very sort of big scale, deep information work, inundated with lots of information. And so as a part of Thrive, one of the many things I'm doing is trying to come up with and validate different ways that I think people should be interacting with information using some of the newer AI technologies that are coming out. And so a lot of the ideas that I want to share today are in part informed by some of the things I've been learning through this process. My brain's been a little bit scattered recently because I've been doing a bit of traveling with the holidays and whatnot. But in that traveling, I've been sitting on the plane a lot, and I live in New York. I work a lot in San Francisco, and so I do a lot of this like cross-country travel. And if you do long flights a lot, you'll obviously have seen this like center console that you have to stay at or stare at when you're on a plane all the time, when you've like run out of your movies to look at and can't fall asleep. And so I stare at the screen a lot. And one thing you'll notice if you do this is that the map that like all of these planes have is the same projection, which is the Mercator projection that dramatically distorts anything that is not on the equator. And so if you fly like the cross-country route, you'll notice that the path isn't straight. It's like a curve on the map, and it looks like you're kind of like taking this really roundabout way to get to your destination. Of course, this isn't really the case, right? If you look at the path on a globe, you're looking at a geodesic, the shortest path between these 2 points, or something close to it, accounting for things like the jet stream in the atmosphere. But these 2 different perspectives on the map show you slightly different kinds of realities, slightly different representations of what exactly is going on. And there are 2 very different ways of like looking at your plane journey. But looking at a geographic representation of a journey is only one way to represent what's going on. A totally different way to represent a journey is to add in the dimension of time. So this is a representation of many, many train journeys in Edward Tufte's book about design of quantitative information display. And in this kind of data graphic, the horizontal lines are specific train stops between Paris and Lyon in France. The vertical lines are 10-minute increments, and all of the diagonal lines are different lines of trains that connect these cities. And so you can see exactly how long, at one glance, you can see exactly how long each of these trains pause, where they potentially intersect on the path or at stations. You can see which trains are faster, which trains are slower. You lose some detail. You've like abstracted out the geographic reality of like where these cities are in relation to each other. But for that, you gain a lot more extra dimensions of information that are maybe more relevant to certain kinds of decision making. And so by representing something slightly differently, you've opened up certain use cases and sort of closed doors on some other ones. A lot of maps like this of places and of journeys are kind of third-person view. I would say both the last one and this one, or you're like looking down from above on what's going on. But you can also imagine maps that are more first-person, right? If you're looking at a navigation system on your phone, you're placed in the map itself, and you're kind of looking around like as if you're like a video game character. And that's useful in its way also. The idea there is that sometimes you don't really just want to know where things are in relation to each other. You want to know where things are in relation to yourself. And the best way you might be able to see that as an end user is if you kind of stand on top of one place in this space that you're trying to navigate and look around and get a very visceral sense for what is close, what is far, what are the directions that I can go in. And I thought that perspective shift was interesting in maps. And so one of the projects that I worked on a fair number of years ago was trying to take that idea and turn it into kind of mapping knowledge. And so back when lots of tools were thinking about, first starting to think about graph navigation as a part of note-taking, I built this little design prototype called Notation, where instead of looking at a graph of notes in kind of a top-down graph view or a list view, you sit on as an end user, you sit on top of like a note page, and the tool will automatically highlight interesting keywords for you that it thinks are sort of the interesting streets to go down, nodes to follow down. And you click on one of these and it'll show you kind of what's behind that keyword. And so the way I thought about this was kind of like if you're in a coding IDE, you click on a symbol and you see what's behind it, and you're navigating a graph by jumping from symbol to symbol. Here you're navigating a graph of information by jumping from idea to idea with the help of this tool that's kind of drawing a map of what is around you around the note that you're looking at. So all these different maps, both for information and for locations, are interesting, I think, because maps shape how we see and understand the world around us and the subject matter that we're working with, which in turn shapes how we act within it. If we see a timetable for journeys versus a geographic map, those are going to lead us to make perhaps slightly different decisions about exactly what factors we focus on when we're planning a trip, for example. Recently, I had a great fortune to visit a team who I think is doing some of the most, for a long time has done some of the most interesting work in the space of visualizing information, which is the visualization team at the Times, the New York Times. And when I visited their office, I saw this amazing wall of some of the key kind of data graphics that they had produced for all of their reporting over the years. And so I had to take a picture of it. And some of these are real maps, right? Like you see some election maps over on the left. Perhaps there are some maps of buildings that are more 3D and kind of interesting there as well. But a lot of these are maps across things that are not really spaces, or perhaps the spaces are really distorted. So there are some maps that are here mapping out like the 50 states, but they're not really mapping out the geography. They're mapping out perhaps the demographic, or it's mapping out a journey to the top of the mountain, but in a very abstract kind of way, or editorial kind of way. There are lots of data graphics that are purely mapping out like quantitative spaces or abstract spaces. You see some maps across time of an athlete kind of like jumping. I thought was really striking in this kind of wall of data visualizations. And
Hey,
looking
Linus,
at, yeah.
do you think you could backtrack for about 20 seconds? I think the connection cut out a little bit.
Oh no, okay.
Yeah.
Cool. Well, so recently I had the fortune to visit a team that I think is doing some of the most interesting work in the space and has been doing for a while of representing information, which is the data visualization team at the New York Times. And so when I had the chance to visit their office, I had to take a photo of this wall that was just a kind of collage of all the different key pieces of data visualization that the team had worked on over the years. And so some of these are real maps, like the maps that you see on the left of the states. Perhaps they're electoral maps. Some of these are maps of buildings. Some of these represent real spaces, but many of these represent really abstract spaces. It might be spaces of demographic information, or spaces in time of an Olympian doing their thing, or you see in the bottom middle there, you see some kind of a weighted map of bubbles building a circle that I don't remember exactly what it represents, but it represents something quantitative in a way that's pretty abstract. And looking at this and the diversity of the maps here, and the fact that most of these aren't actually about representing physical spaces, but a lot of the ideas carry over, perhaps we can rephrase what we just said earlier to say it's not just about maps, it's about representations of information in general. Maybe we can say representations mediate how humans see the world and act upon it, and thereby representations have this power to shape our agency, what we can do within the world. And I want to spend the rest of our time together kind of diving deeper into the implications of this and what that means for people that design representations. Because representations have this power to shape our agency, and perhaps even shape our capability, I think the right way to think about representations is as a technology, just the same way that we think about things like computing or AI or timekeeping. Representation is a technology that can extend our capabilities in opinionated ways. I first started thinking really serious about representation in this abstract capacity a couple of years ago, when I got really interested in notations, the way that people write things down. I spent a while chasing down this idea that a key component of why humans have gotten really smart over the years and really capable intellectually over the years isn't just that we had better automations or that we learned to communicate better with language. I think I had this hypothesis that a key component of our intelligence is also that we developed notations that we could write down and share and communicate with that was, in a really real sense, an externalization of things that we had learned about the world. Like if you like write programs or draw maps or write numbers down, those notations encapsulate something real about the domain that you're working in, like mathematics. If you're writing music down, the music notation, probably there are details in there that capture something real about harmonics and tones and times and what humans find aesthetic. Same with diagrams in physics and dance. Dance is a really interesting example in particular because the space of possible movements and timing and gestures if you want to express in dance is really diverse. And for a long time, I'm not a dancer, but from what I've heard, dance was really hard to notate because the sheer dimensionality of the kinds of things that you would want to write down about someone dancing. And there have been all these different kind of attempts to try to innovate and create new notations in dance, and they would be good at expressing some kinds of dance and not other kinds of dance. And then what really revolutionized dance notation was video. online video where someone could just take a video and maybe add some commentary on top, and that would be kind of a canonical written down version of the dance. And obviously that captures a lot of the details you would never be able to write down, and that could be a way to kind of write down video or write down a dance when it's kind of so high dimensional and so dynamic. But all these different things are encapsulations of intelligence, of information that we know about a particular domain that I think have really effectively increased our capability and our agency in the world. And the question that I asked in the notational intelligence piece was, given notations are so powerful and they're also fairly hard to invent, is there a way that we can get better systematically at the skill of inventing new notations? Can we more systematically try to enable humans to do this thing that has a lot of power that notations give us, which is to see and speak of and manipulate new ideas and abstractions? And so further down, I eventually from notations, I went to looking at visualizations and other kinds of information representations, of which obviously there's a long history. So I wanted to share some other examples that I thought were really interesting. One of my favorite examples of data visualization, in particular in connection to machine learning, is this work from Google's Pair Lab called Communicating Model Uncertainty Over Space. This work takes a model that I believe is, if my memory serves, an oncological model. So it takes an image of a tissue, cells in a biological tissue, and for every small pixel or patch in the image, it tries to output a probability prediction for how likely is that there's something there that we should be worried about. And the prediction is a 3-class categorical probability prediction. So a region can be good, which is green. It can be pretty bad, which is red, and then it can be kind of something that a human should look at and be worried about, which is yellow. And the output is a probability distribution over all 3 of these things. And so it's a 3-variable thing. And you would imagine that's a pretty simple kind of output space. And I think intuitively, I expected the way to visualize this to be pretty straightforward. But this work actually spends a ton of time and effort covering a surprising variety of all these different ways that you can try to visualize that space and trade off subtle things that are really important to experts that are working with this technology in the field, but may not be obvious to just a designer that's new to this problem. So one example of a trade-off they have to make is you want to cover the image with these pixels to communicate the model's prediction, but at the same time, you don't want to obscure the image so much that the human expert can't see through the visualization to the underlying image and use their human judgment that they've honed over the years to compare what they know versus what the computer prediction knows. I think in a lot of these cases, combining human expert and model prediction, often you get the best results if the human exercises their judgment, but then also trusts the model's output and sort of combines your judgments. And so balancing these things like that, the authors of this work spend a lot of effort going through dozens and dozens of design variations to ultimately arrive at something. But the more interesting thing to me was just the diversity of notations and representations that they put time into studying and evaluating. A little bit more closer to kind of my space is representing programs. And so this is work that JP Posma presents at Strange Loop a while ago, which is about visualizing the internal state of a program that as it's executing. At the top, you see a little JavaScript program with some counters and numbers that go up during the program. And at the bottom, he's kind of transformed the program into a form where you can instrument the program and extract some values out as it's running so that you can plot these spark lines next to variable initializations in the original code. So this is, in some way, you're like adding the time dimension back into the code, where if you're just looking at the code, you have no idea what's happening while the program is running. But now you can see, for example, that the variable I on line 6 is like increasing linearly, whereas the variable A in line 2 might be increasing more exponentially. And that might help you to debug and get a sense of what's going on in the program. So it's a different way to see the time dimension in a program. Even more closer to my world right now is visualizing internal states of neural networks. So this is a work by a research group at a publication that used to be called Distill, that is about visualizing internal states, internal concepts that are going through a neural network, in this case, a computer vision model, as the information is being processed. And they've pulled out different neurons, I believe, and kind of try to imagine what the concept is that the model is trying to represent with that part of the model and try to visualize it on a map. And I won't go into all the exact details here, but if you learn to see what is going on and sort of grok a little bit of the details of what the thing is visualizing, it gives you a much more direct sense for what concepts the model might have learned, and even things like why a model might have made a misprediction by looking at this kind of visualization. So these are all different ways to see what's going on in an otherwise kind of hidden system. And in all these cases, I think it's worth noting that the reason that we make these visualizations between the biology case all the way down to the machine learning case isn't just that we can see what's going on. Obviously, that's interesting and for the intellectually curious, but I think it's also important to note that we care about seeing what's going on because it lets us take meaningful action on top of it. We need to see exactly what's going on. The better we see the output of the ontological model, the more meaningful diagnosis we can make and the more meaningful clinical action we can take. The more we can see what's going on behind a program executing, the more meaningful action we can take to debug that program or to perhaps to try to fix a security flaw in the program and so on. And so in general, if we can see what's going on more, we can exercise greater agency over a system that we may not understand. And I think this point of this relationship between seeing things very clearly and greater agency for the human operator of a complex system is really important. When we build these visualizations and more, even in creative domains like picking colors or adjusting sound, or in my specific field in model interpretability, a lot of the reason that we care about understanding what's going on in these systems and visualizing it and presenting it in a form that's intuitive is because it gives us greater agency over the domain that we're working in, whether it's information or understanding machinery. I think this concept of agency is really interesting in software design because it's been with us in various forms for a long time, and it's kind of persisted in various forms throughout history, but it's transformed a lot. My favorite example to go back to is anytime you use a web browser, anytime you load a web page, the browser sends a request, and as a part of the request, there's this header called the user agent header that tells the server exactly what browser is being used, or exactly what agent of the user is requesting the web page. There's a cool kind of poetry to it in that it's sort of implying that the web browser is an extension of the agency of the user. And I think that was the dream of the web browser in the early days, especially where if I wanted to get some information and load a web page, the browser was kind of acting as my agent to go out and fetch that information from the right source, interpret it the right way. Sort of in the early days, it would be also kind of file type negotiations that the browser could do with the server, bring it back, display it in the specific format that I wanted when web pages were less opinionated about style. And so there was much more agency that was an extension of the end user rather than an extension of other parts of the system. A little bit more recently, and perhaps relevantly to a lot of agent-related discourse that happens in the last few years, is this work, which is, I think, one of my favorite things about the concept of agents in software design. This is a written version of a debate between two experts in AI and software design, where they talk about, given the recent advancements in AI technology, in things like speech-to-text and text-to-speech, and models' ability to understand human language, is it still worth building interfaces? They argue. One of them argues, is it still worth building interfaces where the user has to go in and understand everything about the domain and directly manipulate things? Or perhaps can we have software that is what one of them calls an interface agent, where they understand the user's preferences, they can receive natural language instructions, they can go and accomplish things on their own and sort of be a little more kind of natural way to interact with information and with the computer. And they go into lots of little details and interesting examples about cases where one might be more preferable than the other. And the crazy thing about this debate is that this is the same debate that people are having today about modern AI systems, but this particular debate happened in 1997. And so it's almost 30 years ago, and when I found this work, I was just floored by the degree to which the debate and even the specific details and the examples have barely changed between 1997 and today, even though underlying technology and capability set have changed dramatically. And I think that says something about the fact that perhaps the debate between direct manipulation and interface agents, how much to give the agency to the system versus to hold the agency for the end user, maybe that's less about the technology and more about something fundamental about how much humans how humans like to interact with automations and information. This debate has, I think, gotten only more complicated over the years because in modern software systems, whose agency modern software systems serves, I think, has only become kind of less clear over time. And so if you take an example application, like let's say like a social media feed app on my phone, you can ask the question, like, whose agency is that app serving? Well, the most direct answer is that the app is on my phone. I determine when to open it. I determine what to search on it. I determine whose profile I see and what messages I send. So like maybe it's an agent of the end user. And you'd be kind of right. But there are a lot of things that I can't do on the app that I really kind of should be able to do that the software designers have blocked off for me. Things like rate limits and things like what usernames can I choose and what color should the icon be and all these things that are designed by the software designer that, or there isn't really a great reason why that's the case. It's just the discretion of the designer. And so the software is in some ways an extension of the agency of the software designer as well. Between the two, outside the two of them though, there are also lots of parts of the social media app experience that are a function of more like market incentives. Things like how often do I see ads, or if you're in like a dating application, who do I see in the dating application? Or if you're in a news app, exactly where the articles are placed and what kind of advertising you see. All of these are not really an expression of the intent of the designer or the end user. They're kind of an expression of intent is maybe not the right word, but a consequence of something more abstract in the marketplace in which this application is being built. And then lastly, for any software tool that uses machine learning algorithms or heuristics, there's lots of kind of ripple effects of optimization targets and other kinds of heuristics that people choose, where like if I open my social media app, maybe I see lots of videos about like traveling to Europe. And nobody really knows why I see that. It's a kind of abstract consequence of the machine learning algorithms that have been put into the system. And so in modern software systems, agency is really distributed between all of these different things that go into building software and maintaining it. And I think that makes it ever more difficult to really reason about exactly whose will the software tool is carrying out. And I think that's true in general of any complex mechanical system. The more complexity you add to a tool, the natural tendency is to take agency away from the user, not out of malice, but because if you make something more complicated to make it more powerful, a lot of times to make it usable, the easiest thing to do is to hide that complexity. Instead of forcing the user to learn what's going on, you can just say, press this button and the thing will happen. Don't really worry about exactly what's happening. You kind of hide the detail, and by hiding the detail and preventing the user from seeing exactly what's going on, you're making it easier to use, but you're also taking some agency away from the user. This is sometimes fine. I think oftentimes we do this intentionally or unintentionally. And I think doing that unintentionally is probably bad. And I think we can fix some of this by focusing on building a diverse and accessible set of representations for what's going on inside these software systems or inside these complex piles of information. And by doing that, I think we can help the user recover some of the agency that they have over the complexity of whatever they're doing. A recent example of this that I found was interesting is from this work. From Martin Wattenberg and his lab, where the work, they take this observation that a lot of complex machines that we work with day to day, things that we think of as machines and not software, they have dashboards. They say cars have gauges, ovens have thermometers, coffee makers have blinking lights. Our mechanical devices constantly tell us about their internal state, and for good reason. Knowing what's happening under the hood lets us use machines safely and reliably. And this telling us about their internal state, this is often not things that are strictly necessary for operating the machine. Like the dishwasher doesn't technically have to let me know exactly what stage it's in, but it's useful. The car doesn't technically have to tell me, the tire pressure at all times, but sometimes it's useful for us to safely or more confidently operate the machine or operate it more robustly. And they take this idea and carry it over to interacting with language model systems, where they prototype, and now I learned recently that they built something like this and have tested it where they imagine, in addition to talking to a language model, maybe the user should also see a little dashboard where they see critical details of the system, like, does the model think I'm asking for a fictional story or a nonfiction story? Does the model think it should be confident or assertive versus it should be a little bit more cautious? What does the model think about me? Does the model think that I'm an academic? Does the model think that I'm a student? How does it influence its answers? And so they mock up this dashboard that is sort of like a gauge or a dashboard for a language model, which I thought was an interesting concept and something probably spending a little bit more time thinking about what the implications are for how much agency it helps the user recover versus adding complexity and whether that might be worth it. So now we've seen ways that representing internal states of these systems, helping the user see more about what's going on, not only does it help them have some more capability and agency over these systems by just seeing what's going on and having more levers and points of intervention into the system, but it also might help us operate complex systems more safely and more robustly. And this is a really powerful combination that's sometimes hard to achieve, where you get both safety and capability at the same time. This isn't always what you need, though. Depending on exactly the kind of interface you're building, sometimes abstraction away from the user is the right thing. And so I spent some time thinking about that, and I came up with one way that I try to break down exactly what kind of interface you might be building in a way that helps you make this decision, which is, I think, broadly, you can think about the way that humans want to interact with some tool as either an instrumental use case, an instrumental tool, or a deeply engaged use case. Instrumental use cases are use cases where you really just want a problem solved. You don't really exactly care how it's done. So anytime you're filling out a form to get something taken care of, anytime you're calling a service provider to just take care of something, you're paying for something, you're calling a car, you're hailing a service, all of these things, you don't really care exactly how your taxi driver gets to the destination or exactly how your support agent cancels your subscription. You just care that it's done. And in these cases, the correct thing to do is to abstract. The user doesn't really want agency. They actually want to give up their agency and just leave it up to the whatever is executing on the goal. But there are also a lot of times really meaningful kinds of interfaces where the point of the interface is to engage deeply with the domain. My favorite example is a musical instrument, where like the point of playing the saxophone is not to have played a song, it's to actually play the instrument. Otherwise, you would just play a recording of the music. Same with video games, same with a lot of creative tools. The point of using a really powerful image editing tool or video editing tool is not to just have produced a video, it's to explore the possibility space of kind of exactly what kind of edits you can make and the styles that are possible and arrive at the thing that you can arrive at only by sort of engaging deeply with the material. Maps and data visualizations are the same thing. The point is to engage deeply with the information and learn something new, not so much to have taken care of a task. And anytime you're building a more engaged interface, like a creative tool or an information tool, a data plot, something like that, one way you could make these tools better is by showing more to the user and giving them more agency, by helping them express more of their intent more naturally and more precisely, and helping them see their domain from the right perspectives. And so here's, I think, where representations really, really matter. A lot of the examples I referred to earlier about representing mechanisms, things inside machines, things inside like refrigerators and cars and language models. But I think you can apply the same principles to also think about representing information. Back to what I was talking about in the very, very beginning. And this is something I spent a lot of the last kind of year and a half thinking about. And what I've been focused on, one of the things I've been focused on in the last year is to build something that tries to get at maybe a totally different way to represent unstructured knowledge. And so around the end of last year, some research started coming out about this technique called sparse autoencoders that would start to help us disentangle concepts that that deep learning models have learned over the course of its training. And I started getting really interested in the idea of what if we could look at a document or look at a data set or look at an image, not as a sequence of words or pixels, but as a bag of concepts. And what if we could use this technique to take a document and represent it as a bag of concepts that we could detect by kind of shoving this probe inside of a deep learning model as it's reading some input and sucking out the concepts that it's detecting. And so I tried applying this technique called sparse autoencoders onto embedding models, which I was thinking about a lot of the time, and he came up with this technical prototype called Prism, where you would be able to put in any sentence and see a list of all the concepts that a model kind of sees in that input. And then you could even manipulate the concepts on top of that. So you could add in, you could show the model some paragraph, in this case about my research, and dial up the cooking concept and dial down the HCI concept. And it would result in a new sentence where with those kind of remix of concepts that was otherwise a very similar sentence. And you could do this kind of concept arithmetic in a pretty expressive domain of English sentences. And I started thinking a lot about, well, if you could represent a thought as a bag of concepts from a library of concepts instead of as a sequence of words, there are a lot of new kinds of interfaces, new kinds of representations of documents you could build on top of it. You could, instead of summarizing a document, show a heat map over the document for what are the key concepts and where frequently do they occur over the document. This could be an interesting way to get at a glance kind of a hint of the structure of the document or a replacement for a summary. You could show that kind of heat map on like a scroll bar in a news article. So you could say, oh, here's where there was a lot of political discussion versus here's where there was a lot of depictions of disasters or perhaps more victorious moments in an article. You could see that by annotating where different concepts occur. You could also steer outputs in concept space rather than in word space. And so you could imagine there are some tools that sort of try to do this now, but you can imagine a text editor where instead of just bold and italic and underline, you also have things like make more casual or add in quotes or make it more narrative. There are also work that some of my friends have done that I think in other modalities that really inspired me. In one case by a friend of mine named Gitas, who applied some of this same technology to image models to say, actually, in image models too, there's this whole library of concepts you could study where if you could break down an image model and say, here are all of the kind of visual concepts that the model knows about. And you could, again, take an image, dial some of these concepts up or down, and do very abstract edits like apply a sunset over this image, or add it's like my favorite example is the second line where you can like add the toilet concept to any image. And this in a totally different domain, but the same idea of like treating a modality of information as a bag of concepts and building new representations of it. More recently, I started exploring what could that look like if we applied this to like a more real knowledge tool. Like what if you had a notebook where you could still type stuff in, but the way that the notebook thought about these documents was not, again, as a sequence of words, but a bag of concepts. And so you could type something in, it'll show you, here are all the concepts that I see in what you just typed in. Here are other documents that also have the concept. Here, let me color code these documents I pulled up that are related by the concepts that they share with what you just typed in. Perhaps you could plot your entire kind of information library by the frequency by which these concepts co-occur, or maybe you can even discover new interesting combinations of concepts that mean something to you that previously didn't have a word before. So if building new representations like this is so interesting and so powerful, it's worth asking, like, why don't we do this more? Why aren't more people thinking about building new notations or coming up with very, very new kinds of data graphics? And I think there are a couple of reasons why. One reason why is that building representations has a lot of feedback loops that are hard to anticipate. And this particular code actually dates back from less recently than some of the technologies that we're talking about. But philosopher Baudrillard writes about this concept of simulations in his book, where he says, the real is produced from miniaturized cells, matrices, memory banks, models of control, and it can be reproduced an indefinite number of times from these. It is no longer really the real because no imaginary envelops it anymore. It is a hyperreal produced from a radiating synthesis of combinatory models in a hyperspace without atmosphere. A hyperspace without atmosphere, I interpret as something like a taxidermied version of reality that doesn't really take breaths anymore, but it's somehow fixed in space that is still producing effects out into the world, radiating reality out into the world. It may as well be talking about language models hallucinating content or producing reproduced content, and somehow that influencing things, real content out into the world and real actions out into the world, which I think is very apt for thinking about kind of where we are today about how information is affecting reality. But this was written many, many decades ago, and I think that same patterns have persisted across various technologies. To make this a little bit more concrete, I think I found this work recently that takes a look at it tries to look at one particular way to quantify creativity, or at least novelty, and looks at investigates our language models, our frontier language models, better at novelty than human experts, where human experts are sort of historically acclaimed creatives and authors. So maybe they're a higher bar, but what they find is that they could try to quantify creativity by n-gram overlap, by how many word sequences overlap between a training corpus and between what a human writes versus what a language model writes. And what they find is that in this, in this particular example, at least over these domains, language models tend to have greater overlap in sequences of words than human experts in these more creative kind of tasks of writing and poetry and writing speeches. And you can imagine how, as we have more content that is produced by these systems going out into the world, they're going to start to shape the distribution of reality that humans experience in a kind of interesting way. So there are strange feedback loops that we have to think about when deploying new representations, especially new, more complex representations to the world. The other reason that building representations is hard is because it requires taking a stance, an opinionated stance about what you abstract away. I think at one point when I first started thinking of representations, my metric for success was like faithfulness to reality. A perfect representation would show you everything you needed to know without losing any detail. But Borges sort of describes abstractly in this very short story about, he talks about this empire where the cartographers attained such perfection in their craft map making that the map of a single province occupied the entirety of a city, and the map of the entire empire a province. They tried to make the perfect map with all of the details captured. And in time, those unconscionable maps no longer satisfied, and the Cartographer Guild struck a map of the empire whose size was that of the empire itself. The following generations, who were not so fond of the study of cartography as their forebears had been, so that the vast map was now useless because they had jammed every detail into this like perfect lossless map that was as big as the signified itself. And it turns out a map like that obviously is not useful because you might as well look at reality. And so anytime you're trying to represent something, you kind of have to choose a perspective that says these things are not important and these things are what we care about. And there's a bit of editorializing going on. And that means that for different use cases, we have different representations, and there's this tough trade-off you have to make anytime you build a representation of something. And so these challenges remain when we build representations. And yet, these representation technologies are still very powerful. They mediate how we see the world and act upon it, and they have the capacity to shape and extend our agency. And so as we build representations, whether it's data visualizations or models of, models that we can run to reproduce content, I think it's worth maybe having some rules or some tenets for how we might be able to do that in a way that aligns with what we want to affect on the world. So here are at least 3 that I sort of came up with, sitting and thinking about it, about tenets of designing representations. The first is that we need to realize that a representation must necessarily abstract. It must necessarily take some opinionated stance on what things are valuable in a particular use case to abstract away versus to show to the user. Otherwise, the map is useless. And so we should be intentional about what we're abstracting rather than sort of doing it accidentally as an artifact of a design decision. The second is to realize that an interface always gives or takes away agency from the user. Neither is strictly good nor bad, but we should be intentional about when we're taking away agency by hiding something versus when we're trying to give the user more agency and showing something, and we should try to show it to them the right way. We don't want to be accidentally taking away agency from the user when it's something that we should really be giving them. And then third, sort of related to the first point, if we can't build a perfect representation that is always lossless, then perhaps the better goal to focus on is to focus on representation as a way to communicate between humans, communicate between a human and a complex mechanical system, or a human and a complex data set. And if you look at it that way, that makes natural sense to abstract and to take an opinionated stance and to accept that there is some amount of narrative building going on when we're building these representations. The reason I'm interested in representations at all, and giving the user agency at all, is because I think the dominant narrative in technology right now in machine learning is to chase the magnitude of the capability that we have. This thing called superintelligence. We're trying to build tools for superintelligence. But I think as we have this longer and longer lightsaber that we can wave around to get things done in the world, it's also worth thinking about how we can help the human pointed in the right direction as precisely as possible. And I think of it as kind of parallel track of work that I think we could call like building instruments of super agency. In addition to extending our capability, how can we make sure that we can point it in the right way? And I think this is ever more important than before because our relationship to information sort of fundamentally changed over time, where we went from working with individual documents and paragraphs and books to working with navigating libraries and data sets. It's sort of like having gone from nurturing little gardens of ideas to exploring really, really dense forest, adversarial, dark forest for truth. And in this increasingly complex information environment, I think we should think about how we can build tools and interfaces to help us move forward in a way that extends rather than extinguishes, as is the natural tendency or agency in complex information environments or in complex mechanical systems. Building these tools are going to be hard. We need to build tools and representations that let us see deeper and further and broader into these spaces. And oftentimes that'll mean that we have to kind of force the user to contend with complexity. But if we solve those tough problems, then when we finally get there, we'll have new ways of seeing the world and new places for human agency to intervene and have our technology more aligned and more capable because they are aligned with the way that we want to affect change in the world. And that, I think, is the power in representation. Thank you very much.
Thank you so much, Linus. That was really amazing. And I usually start with some questions of my own, but there were so many questions in the chat. I'm just gonna jump right into some of them that went on chronologically. So again, if anyone has any questions, you feel free to write in the chat and then we can get to it after I go in chronological order. Okay, so the first question is from Kshitij Gupta. What are your thoughts on visualizing these high-dimensional embeddings in a 2D space? Can this be designed to augment understanding, or will there always be a danger of oversimplification? Which I guess maybe was answered later in your talk.
Perhaps I can get a bit deeper into it.
Mm-hmm.
I think what you're really doing when you're using these dimensionality reduction techniques on high-dimensional spaces is the opinionated stance you're taking when you're building that visualization is you're saying the most important, or like in this case, what is most important is a definition of a distance in the space. A lot of times this distance metric is Euclidean distance or cosine distance, but you're saying, what I really want to see is I want to get rid of a lot of the other nuances of high dimensions, but just see how things are in relation to each other in terms of distance. And that is, you're making an opinionated claim that is the most important thing and using that metric to simplify things down. This is useful if you're trying to do things like take a similarity model and trying to see where things cluster. But I do think it removes some detail. For example, for most of these nonlinear dimensionality reduction techniques that are really good at preserving distance metrics, that what they trade off is they're pretty bad at preserving linearity. So if you draw a line through a 2D collapsed version of a high dimensional space, that direction is not going to mean anything. Like going up in the diagram is not going to mean anything. And oftentimes the direction is actually sometimes you care about more because in the native kind of ambient space of the model's latent space, a direction might mean something really, really useful that you want to not only understand, but to maybe intervene on to steer. And so it just depends on kind of what you deem important when you're looking at the high dimensional data. Something I'm quite optimistic about these days is to focus more on the dimensionality aspect, or focus more on the direction and space aspect, and somehow let end users query for, plot me or show me the data points in this space, but by these directions, by like the sentiment direction and by the topic direction. And then you only have to care about metrics along those dimensions. It's sort of like flattening the other dimensions out that you don't care about. And perhaps that could do a better job of preserving both the metric definition, the definition of distance, and the meaningful directions in the space.
Yeah, amazing. Okay, the next question we had is from Jen. Curious if you see notation to continue to be a human artifact as AI starts to take over more busy work and step in as a teammate or assistance in collaborative work.
That is a good question. I think there will be a version of it that exists. I mean, there already is a version of it that exists for computers, like protocols and interfaces between software systems that you could kind of call the notation. Ultimately, I think humans care a lot about retaining control and retaining power and agency. And I think to do that, humans need a way to specify what computer systems want to do. And to me, it feels important that if we want to have that power, then we should have, like, it feels important to have tools or have ways to describe things where we can be really precise about what we want to describe. And I think as these things become more capable, like if you think about a particular domain of science, like physics or biology, our vocabulary and annotations have only gotten more and more specific and more sophisticated as the field has advanced. And I think that's probably going to continue. And I think models can help us discover new concepts and perhaps even embody them into notations. And we'll use those to communicate. An interesting kind of sub-question that I sometimes think about that's related to this is like, if we get sort of direct to brain neural interfaces, will that obviate the need for notations? I don't think so, because a part of the value of notation is it gives us vocabulary and it gives us precision. And like, even if I could beam my emotions directly to you, it feels important that I could be precise about saying, oh, I feel this very specific way, and let's give that a name and let's talk about it. And let's maybe like gather a bunch of people who also feel this way, and we'll have some way to refer to that, even if it's not by a word or by sound. Maybe it'll be some like binary sequence of like sparks or whatever in our brain, but there will be some way to refer to it, and I would say that is still notation.
This is actually a great follow-up question. It's almost like they were asked this in real time, but have you seen, this is from Jonah, have you seen examples of physical products displaying data to users that can be manipulated to suit the changing needs of the user?
Ooh.
Yeah, like we were just talking about the hypothetical physical.
Yeah. I don't have any great examples top of mind. I think like clocks and calendars are always interesting.
Yes.
There's also like abstract, like obviously there's like literal clocks and calendars. There's also things that kind of denote the passage of time that are not clocks, but they basically function as one. Like if you have a bulletin board and like, yeah, the start of the semester, it's empty, and then like over time it like fills up, and depending on what's on the bulletin board, you can kind of see what time is in. There's like interesting ways that you could kind of say those are like data displays that sort of implicitly denote time. Yeah, I'm not sure. That's a great question.
Okay, and then the next question from Steve. Hi, Linus. I like your ideas that interfaces are like maps that let users have a grasp of different layers of information. What's your take on spatial 3D interfaces? Actually, we kind of talked about 3D interfaces. Anyways, compared to 2D interfaces, what are the advantages, disadvantages? Where do you see the interface will go in the future?
I kind of thinking aloud here, so this isn't the most thought out response, but spatial interfaces in general, I think are really cool. There's a great blog post whose author I unfortunately can't remember, but I think the title is literally called Spatial Interfaces, and it begins with this idea that like it would be impossible to try to build a piece of software that emulates a deck of cards, because like with a deck of cards you can like shuffle it, you can like share it out with your friends, you can pick a random card. None of these things you can, it's like very hard to emulate those things in software. You can't like take an iPhone app that is a deck of cards and then like shuffle the cards out to people. That's not something you can do with an app. There's this like materiality and embodiedness in a deck of cards that you can't emulate in software. I think that kind of thing gets even more exaggerated in 3 dimensions, because the 3 dimensions are the thing that your body exists in. And so you can have like something that happens very viscerally in 3 dimensions that doesn't happen in most 2-dimensional spatial interfaces, is you have a sense of scale. Everything in 3 dimensions exists in relation to the size of a human, which is not something that happens when you're like, looking at a Figma board. You have no sense of like a cursor doesn't have a size. And I think that can be used to great effect for anything that requires a sense of scale or to like zoom in and out.
And we still have so many questions and not enough time, so I'm gonna just ask a question that has come up multiple times, which is, do you rely on particular writers or frameworks, or if there's any literature that has the biggest impact on grounding reality. So any kind of, I think people they want an assignment, they want some readings.
I feel like a lot of the problems that people try to solve are like very classic problems. Like, as I was putting this kind of talk together, I really enjoyed going back and trying to find historical references that feel like you could have pulled them out of like off of Twitter yesterday, but actually they were written by a philosopher in the 1980s. Like, I think looking at historical work for human relationship to information, human relationship to symbols evolve, all of those are interesting because by cross-referencing across these different periods, you can find the things that are not going to change. Like the fact that people have argued about direct manipulation versus agents for so long is probably a testament to the fact that that's mostly a human thing and not so much about the technology. And so I would say, in particular, like maybe to be a little bit more concrete, there is a period of time between like at the dawn of the personal computing era, from like mid 1970s to like early 1990s, where like personal computers are like more or less a thing. People thought they were going to be big, but like nobody had really like won the interface war yet, and so people just threw a bunch of stuff at the wall and saw what stuck. And there are a lot of historical work you can find documenting different kinds of interfaces that people tried to see if they would work, and I think that's a really interesting area because people had enough technology that they could really test things out, but nobody had really won. So there's a lot of creativity, and so I would encourage people to look at like for example, a lot of the experiments that were done at Xerox PARC were like early Mac desktop.
Amazing. And just to answer, someone had asked if Linus publishes any of his work. I'm going to post a link to his website in the chat. It's the cephas.com. So you guys really, I encourage you guys to read a lot of the works that Linus writes. And I don't want to keep everyone for too long, but I think we still have so many more questions, but I just wanted to say before you know, that we do have 2 more talk series. Zach posted the link in the chat. I'm going to post it again. The next one is next Friday. Maggie Appleton, who is an anthropological researcher and particularly writes about tools for thoughts and the history of that. So I think it's a really nice kind of retrospective on the kind of things that we were thinking about today. And also the talk series will be available online. We are recording this once we get the transcriptions ready. So I don't want to take up so much of everyone's time. So I'm gonna say thank you so much, Linus, for your talk, and everyone, you know, we can continue this conversation online. And so, yeah.
Yeah, thank you for having me
you.
here. It was a pleasure, and you can find me very easily online. If you have any questions, I'm happy to jam on any of these ideas outside of this.
Okay, thank you.